The metric aggregation pipeline processes incoming data points into fixed time intervals. Raw metrics arrive at variable timestamps and are bucketed into configurable windows. The default window size is 60 seconds. Bucketing occurs synchronously during ingestion. Points that arrive outside the current window are directed to the appropriate historical bucket based on their timestamp. The pipeline maintains a sliding window in memory to minimize allocation overhead. Roll-up aggregation compresses granular metrics into coarser time buckets at scheduled intervals. The system supports hierarchical roll-ups across multiple time dimensions. Primary roll-ups occur every 5 minutes. Secondary roll-ups consolidate 5-minute data into hourly buckets. Tertiary roll-ups further consolidate hourly data into daily buckets. Each level of roll-up applies the same aggregation function to its input set. The aggregation function is user-configurable per metric namespace. Aggregation functions define how multiple data points combine into a single value. Standard functions include sum, average, minimum, maximum, and count. Custom functions may be registered through the plugin interface. The sum function adds all values within the bucket. Average divides the sum by the count. Minimum and maximum return the lowest and highest values respectively. Count returns the number of non-null points processed during the interval. Bucket retention policies determine how long aggregated data persists at each granularity level. Fine-grained buckets retain data for 24 hours by default. 1-hour buckets retain data for 30 days. 1-day buckets retain data for 1 year. Retention periods are configurable at the metric namespace level. Data exceeding the retention period is automatically deleted during the next maintenance cycle. Deletion operations are performed asynchronously to avoid blocking ingestion. Missing data handling during aggregation follows a configurable strategy. By default, missing points are treated as zero values in sum and count operations. Average operations ignore missing points entirely. When the total number of points in a bucket falls below a minimum threshold, the aggregated value is marked with a missing data flag. Downstream consumers can filter on this flag to exclude uncertain results. The minimum threshold defaults to 1 point per bucket. The aggregation scheduler manages timing for roll-up operations across multiple time horizons. A background thread monitors system time and triggers roll-ups when bucket boundaries are crossed. Scheduling operates in UTC time zone exclusively. Daylight saving time transitions do not affect bucket boundaries. The scheduler maintains a queue of pending roll-up operations. Operations are executed serially to maintain consistent ordering. Completion time for each roll-up is recorded for monitoring purposes. The aggregation cache layer maintains recent buckets in memory for rapid retrieval. Hot data consisting of the current and previous 2 time windows remains permanently cached. Older buckets are removed from cache when new time boundaries are crossed. Cache hit ratio for typical workloads exceeds 95%. The cache uses LRU eviction for overflow conditions. Queries against cache data require no disk I/O. Cache coherency is maintained through invalidation on aggregation completion. Metric tagging allows operational metadata to be associated with time series. Tags are key value pairs stored separately from aggregated values. Common tags include service name, environment, and region. The aggregation pipeline preserves tags through all roll-up levels. Aggregations cannot occur across different tag values. Each unique tag combination represents a distinct time series. Tag cardinality is tracked to identify potential performance issues. High cardinality tags can significantly increase storage requirements. Downsampling provides a mechanism for reducing storage overhead of high-frequency metrics. When downsampling is enabled, only a percentage of incoming points are retained. The percentage is configurable per metric namespace. Selection of points follows a deterministic algorithm based on the metric name and timestamp. This ensures reproducible downsampling across multiple instances. Aggregate functions automatically account for downsampling by scaling results appropriately. The downsampling ratio is stored with each aggregated bucket. The pipeline supports rate calculations for counter-type metrics. Rate aggregation computes the change in value divided by the time interval. Negative rates occur when counters reset. The pipeline detects and handles counter resets automatically. Rate calculations operate at the finest granularity level only. Coarser buckets aggregate the pre-computed rates rather than recomputing. This approach prevents mathematical distortion at different time scales. Rate precision depends on the underlying counter resolution. Percentile calculations within aggregation buckets operate on pre-computed histogram data. Incoming points contribute to histogram bins rather than raw value storage. Percentile aggregation merges histograms from multiple points into a single distribution. The number of histogram bins is configurable with a default of 100 bins. Higher bin counts increase accuracy at the cost of storage. Percentile queries retrieve pre-computed values from histogram metadata. This approach avoids storing raw point values at scale. The aggregation consistency checker validates data integrity across roll-up hierarchies. The checker runs periodically on a configurable schedule. It verifies that coarser buckets accurately represent their constituent finer buckets. Discrepancies trigger an alert but do not halt pipeline operations. Common causes of discrepancies include incomplete data collection and timing skews. The checker logs affected time ranges for manual investigation. Automatic healing is available for correctable errors. Backfilling allows recomputation of aggregations for past time periods. This operation is necessary after correcting raw data or updating aggregation functions. The backfill operation specifies a time range and target granularity. The pipeline reprocesses all raw data within the range. Existing aggregations at the target level are overwritten. Coarser aggregations, depending on the recomputed buckets, are invalidated. Backfill operations may consume significant system resources and should be scheduled carefully. The pipeline exposes metrics about its own operation through a dedicated namespace. Metrics include bucket processing latency, aggregation function execution time, and cache statistics. These internal metrics follow the same aggregation pipeline. This creates a recursive feedback loop for monitoring pipeline health. Performance regression in the aggregation system becomes visible through increased latency metrics. The reserved metric namespace begins with an underscore prefix. User metrics cannot begin with underscores. Metric drift detection identifies anomalous behavior in aggregation results. The drift detector maintains a statistical model of normal metric behavior. Models are trained on historical data and updated continuously. When a new aggregation falls outside the expected distribution, a drift alert is generated. Alert severity depends on how far the value deviates from the expected range. Drift detection is optional and must be explicitly enabled per metric. False positive rates are tunable through configurable sensitivity parameters. Graceful shutdown of the aggregation pipeline ensures no data loss during system termination. An in-flight aggregation set is maintained for buckets currently being processed. The shutdown routine waits for all in-flight aggregations to complete. A timeout of 30 seconds is applied to prevent indefinite blocking. Any incomplete aggregations are written to a recovery log. The recovery log is processed during the next system startup. Log entries are deleted after successful reprocessing. Shutdown status is logged for operational diagnostics.